Hello everyone, welcome back to yet another video on my channel. This video is going to be a sequel to the last video. In the last video we looked at custom density functions and noise routers where we could generate custom terrain, and we created this really cool terrain around us, and I think it looks pretty cool. Of course we can do a lot more with this, and like I said in the last video, there are endless possibilities for this. As we saw, you can literally customize every aspect of the world. You could get down to every single block almost if you wanted to. Right now, what we're going to look at is something called surface rules, and that is going to let us change the default block of the world based off of conditions such as the current biome that we're in, or how high the block is from the surface. For example, how in vanilla the grass blocks are always on top, they're on the top layer, and the dirt blocks are in the few layers below that, and then below that it's stone, and even farther down it's deep slate. How does vanilla do this? Well, they use surface rules, because currently all we can do is have a single block as our world, and that's a little boring, isn't it? So without further ado, let's get started. So just to review, we've got our final density function here in the code inside of our noise router, and this final density function adds together a y-clamped gradient which starts out from the bottom of the world and goes to the top of the world, changing a constant value from 1.25 to negative 1.25. And that basically makes sure that there's the ground and there's the underground, and then there's also the sky areas of the world. And then our second argument here to the add function is our noise itself. And this is a custom noise that we defined over here using a first octave of -7 and these amplitudes right here. And of course, all of this you can customize and tweak around with. That's the most fun about editing data packs, is that you can make literally anything you want, especially within these super large parameters that we have here. There's not much limiting you in terms of final density functions and noise routers. So next, we're going to look down here at this little property. We just added this in the last video. We added the surface rule type of sequence. And the reason we added this is because we do need something to be here in order for it to work, but we want to go ahead now and add actual surface rules inside of this. So let's go ahead and define our first surface rule here. Inside of this sequence, this array is a list of surface rules that will be applied in order as they go down. And if a block matches any surface rule, then it stops checking and applies that one surface rule. So we want to apply the most important ones first. So let's go ahead and start with the simplest one, which is a block surface rule. So we'll set type block, and we'll set result state with a name of Minecraft oak log. And believe it or not, that's actually all we need to define our first very basic surface rule. So we're going to do the same trick we did in the last video. Go to your save folder, dimensions, my data pack, and delete custom dim, which is our dimension name. And now we can go back to Minecraft and load up our world. And as you can see, our surface rule has worked and everything is oak logs. The reason everything is oak logs is because all we did is say type of block. We don't even have a surface condition yet. But as you can see, every single block everywhere is oak logs. And that's what we expected from this surface rule. Next, we're going to go ahead and do the next simplest thing, which is a very, very simple condition. So we're going to remove this result state field here, and we're going to change the type to condition. And inside of condition, we've got a few more fields. We've got if true. And if true takes a surface condition, and the surface condition can also have its own type. And we'll use a simple one, stone depth. And so then we get a few more properties on stone depth, one of which being surface type, which we'll set to floor because our biome only has a floor and it doesn't have a ceiling. So if it had a ceiling, we may want to modify the ceiling, in which case we would set this to ceiling. Then we're going to set offset this will be the distance from the top of the world that this rule is active. So what this rule does is it checks for a block if it's within a certain range of the highest block on the terrain generation that was generated up here by our density function. And if that block is within the specified offset, so we'll say 3, then it's going to return true for this surface condition. There's also a few more required fields we have to add. Add surface depth, false. Surface depth is a random value that's hard-coded into Minecraft, and that essentially allows the depth of dirt in the vanilla game to vary across the terrain, so that sometimes the stone might be higher up than other times. However, we're just going to focus on the simplest use case here, and we'll set this to false. Then we need secondary depth range, and we can just set this to 0 because all this does is allow us to add this surface depth value. Now, if this condition is true, then run, and we'll have our surface rule again. This is the same thing we have defined up here, and so we can use the block surface rule if we want. The only difference is this time it's only going to be active if this condition returns true. So we'll set result state to be name Minecraft oak log. Then back in Minecraft, we should see the same thing on the outside, but if we dig underneath a little bit, we'll see that we still have this red concrete underneath these 1, 2, 3, 4 layers of wood. And the reason it's 4 is because when we set the offset to be 3, there was already a depth of 1 that was present by default. So if we set this offset to 0, it would still replace the very top layer with oak logs. However, we set it to 3, so it's going to add 3 to that 1 layer that's already present. And hey, if you made it this far in the video, don't forget to like and subscribe. It really helps the channel out. And if you subscribe, you won't miss any new videos that I post, because I'm going to continue to make videos just like this one, diving deep into concepts about data packs in Minecraft. Thank you, and let's get on with the video. So let's see if we can do something a little more practical with this. Let's try and set our offset to 0, just like I was saying. And instead of doing oak logs, we'll set this to red carpet. And this will go with our theme of our red forest. And going back into the world, we'll see everything is covered in red carpet, but it's only 1 layer. As you can see, we've still got our red concrete right here, and everything else below this is also red concrete. Now that we've done that, I'm going to show you how to use multiple surface rules to define several sets of conditions that can be applied in order to select the right exact block state for each position. Inside our sequence here, we'll create a new surface rule with type of condition again. And we'll say if true, and this time we're going to use a different condition type. This type will be y above. And its additional parameters, we'll say anchor, and this is an anchor object, which the easiest way to define would be to just say absolute 75, for example. You could also say above bottom, or if you wanted, you can even do below top, but we're going to stick with absolute because this is the easiest. And this Y level is exactly what you would see on the F3 screen. We also need to have a surface depth multiplier, and we'll set this to 1 because we don't want the surface depth to impact anything. And we'll also have add stone depth, which will be set to false because again, we don't want stone depth or anything like that to affect our condition. So if that's true, then run a type of block with a result state with a name Minecraft oak log. And so now we have 2 conditions defined. First, we've got this stone depth condition, which places red carpet if the block is within an offset of 0 of the surface type floor. And then if this one fails, so essentially if the block we're currently looking at is not within the top block of the surface, then we'll move down here. We will not move on to this condition if this condition returns true. So if this turns into red carpet, nothing else will happen, but if it does not, then we'll move on to this condition where we check if Y level is above level 75, and then we set the blocks to the oak log. So for each block, if it's above level 75, we'll have an oak log. Let's go ahead and see that in action. And here we are. We've got carpet, oak logs, but if we go down a little bit, maybe we can see it down here. We can see that the red concrete is peeking through down here. So up here, if we look at our F3 screen, 78, 76, 75. So below 75, we've got all red concrete. And if Y is above 75, like right here, it's 76. Not sure exactly why it's red concrete over here, but it should be oak logs at 76. Who knows? But above level 75, then we have oak logs, except for where we have our red carpet, which, as we remember, that was in our very first condition here. So anywhere where there's red carpet, that's because that condition matched first, and it didn't even get to move on to the condition where we set our oak logs down here. Now we're going to look at another type of surface condition, and for that we're going to remove all of these just to clear things up so that you can see everything more clearly. And we'll set this as a type of condition yet again, and we'll say if true, and now we'll define our condition with a type of noise threshold. And this is where we can actually use the same noise system we discovered in the last video to define where we want different blocks to generate. Noise threshold gets a few parameters, the first one being noise, and we can set our noise ID. We'll leave this blank just like we did in the last video for now, but we'll come back to it in just a second after we fill out the rest of our parameters. The next thing we have is min threshold, and we can set this. This is the minimum noise value where the condition passes. So this is our condition, and this is our condition, and we want our condition to pass if the noise value is at least, let's say, 0.0. And then, similarly, we have max threshold, and we want the condition to pass only if the noise value is below this number. So just to make things simple, I'm going to set this to really high, for example, 100. It's always going to be lower than 100. What this means is that as long as it's above 0.0, then we're going to return true for this condition, and we're going to move on to the then run field here. And the then run, type, block, result, state, name, Minecraft. And this time, let's do purple concrete. That way we can see the difference very clearly, because purple and red, well, they're different colors. We should be all good on this except for our actual noise value here. And so for that, let's go to our noise folder, create a new file called surface noise.json. And again, we'll have first octave. I don't know, let's do -4 for this one. And we'll have amplitudes, and we'll just do a 1, just for a simple little setup here for our noise. Again, we can configure this at a later time. We'll figure this out in a second. And we can go ahead and set my data pack surface noise as our noise provider here. And then let's go ahead and get back into the game. As we can see, we now have a very clowny looking world here, a little bit spotted, but this is pretty neat because we're actually using a noise function to determine what blocks should be what. And, just like before, we can go ahead and edit our surface noise parameters so that we have different values and we have different patterns on the surface here. For example, I bet you can guess if we set our first octave all the way up to maybe like -7, we'd probably have pretty big splotches of purple and red. And so let's go ahead and test that. We're actually going to use -6 because I think that's going to be good enough to see the difference. And so we can go ahead and change that out. When we get back in, we'll see, ta-da, much bigger splotches of red and purple, just because we changed the noise density functions. And maybe if we wanted to have a little bit of an edge, a little bit of a wavy edge, well, we could go ahead and modify our amplitudes over here. 1, that'll be a nice value there. And as you can see, it's very subtle, but we do have a little bit rougher of an edge. It looks a little bit more natural. It doesn't look as smooth and generated and artificial as it did before. Anyways, I think that's going to do it for today. I know this was a little bit shorter of a video, but don't worry, I've got a few more in the works, so stay tuned by hitting the subscribe button and ringing that notification bell. Don't forget to like the video and comment any suggestions you have as well. Thank you so much, and I'll see you in the next one.